Dr. Jeffrey, good morning.
Can you hear me properly, Cherin?
Hi, Jeffrey. Good morning. Yes, I can hear you loud and clear.
Okay, thank you very much.
Tes 1, 2, 3. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Salam, Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning and best wishes to all of us. Tes. Yang terhormat Dekan Fakultas Sains dan Teknologi Universitas Jambi, Bapak Dr. Andes Jeffrey Mazal, MSc, DIT.
Honorable Dean of Faculty of Science and Technology, Jambi University, Mr. Dr. Andes Jeffrey Marzal, MSc, DIT.
Yang Koordinator Program Universitas Jambi, Bapak Edi ST, MSc.
Honorable Coordinator of Information System, Jambi University, Mr. Edi Saputra, ST, MSc.
Yang kami hormati Bapak Swanit Sharancit sebagai kuliah umum.
Honorable Mr. Swanich Haranchit, our speaker for today public lecture.
Formasi Universitas Jambi.
Honorable the Lecturer of Information System, Jambi University.
Selanjutnya, yang kami banggakan para peserta kuliah umum tahun 2000.
Furthermore, we honor and we proud of the participant of the 2023 public lecture.
Puji syukur kehadirat Tuhan Yang Maha Esa yang telah memberikan nikmat dan karunia-Nya kepada kita semua, sehingga kita dapat berkumpul untuk mengikuti salah satu rangkaian acara kuliah umum tahun 2023 dengan tema Energy Saving and IoT.
Today, we will conduct public lecture with the term energy saving and IoT.
Perkenalkan, saya Khairini Saputri dengan partner saya Sri akan menyampaikan susunan acara pada hari ini yang dimulai dengan pembukaan yang sedang berlangsung. Kemudian dilanjutkan dengan menyanyikan lagu wajib Indonesia Raya. Selanjutnya penyampaian kata sambutan sekaligus pembukaan kegiatan secara resmi, dilanjutkan penyampaian doa, kemudian penutup.
I'm ceremony for today's event. The event will begin with the opening followed by the singing of our national songs Indonesia Raya. After that, we will have prayer, an opening speech, and then delivery of the material, including a question and answer session. The last event will be the closing.
Hadirin yang saya hormat dengan menyanyikan lagu wajib Indonesia Raya yang akan dipimpin oleh Dina Veronica. Kepada Saudari Dina Veronica, dimohon untuk maju ke depan.
Honorable guests, let's begin this event today with the following schedule. Let's start by singing Indonesia Anthem Indonesia Raya.
Kepada para hadirin dimohon untuk berdiri.
merdeka, dan aku
Kepada para hadirin, dipersilakan duduk kembali. Bacaan doa sebagai oleh Saudara Rifki. Kepada Saudara Rifki, dipersilakan maju ke depan.
Next, let's us open this event with prayer led by Rifki.
Assalamualaikum warahmatullahi wabarakatuh. Sebelum memulai acara kuliah umum pada pagi hari ini, marilah kita sama-sama mengangkat kedua tangan sambil menundukkan kepala seraya berdoa agar acara kuliah umum kita ini berjalan dengan lancar, ilmu yang diberikan dapat bermanfaat serta menjadi amal jariah. Dan mohon izin, pembacaan doa ini akan saya pandu dengan syariat Islam, diharapkan bagi yang non-muslim untuk dapat menyesuaikan. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdan syakirin, hamdan na'imin, hamdan yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalalika wajhikal karimi wa azimi sultanik. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Allahumma ighfir lana dzunubana wa liwalidina warhamhuma kama rabbayana shaghira wa li jami'il muslimina wal muslimat wal mu'minina wal mu'minat wal ahya'i minhum wal amwat innaka ala kulli syai'in qadir. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizqi wa taubatan qablal maut wa rahmatan 'indal maut wa maghfiratan ba'dal maut. Allahumma hawwin 'alaina fi sakaratil maut wan najata minan nar wal afwa 'indal hisab. Rabbana hab lana min ladunka rahmah innaka antal wahhab. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Saudara Rifki. Selanjutnya, kata sambutan dari Dekan Fakultas Sains dan Teknologi Universitas Jambi kepada Bapak Dr. Andes Jafri Marzal, MSc DIT, kami persilahkan.
We will then proceed with the opening speech from the Dean of Faculty of Science and Technology at Jambi University.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, dan salam sejahtera buat kita semuanya. Honorable Mr. Chairman, as our speaker this morning, para college, dosen, dan kemudian para mahasiswa semua, dan pada undangan yang baik yang ada secara online maupun yang ada di ruangan ini. Pertama-tama, marilah kita sama-sama mengucapkan puji dan syukur kita pada Allah yang Maha Kuasa, di mana pagi hari ini kita diberikan kesempatan, kesehatan untuk mengikuti kuliah umum yang merupakan pertama kali di tahun 2023 ini. Isu tentang perubahan iklim ini merupakan isu yang sudah santer saat ini, dibicarakan di semua kalangan, baik dari pemerintahan maupun dari ilmuwan, akademisi, di mana orang berharap agar ada energi yang ramah lingkungan yang berkelanjutan yang akan ada pada saat ini dan pada masa yang akan datang. Nah, salah satu tool atau solusi yang bisa kita gunakan untuk menyikapi tentang perubahan iklim ini adalah dengan memanfaatkan Internet of Things, atau kerennya kita dengar selama ini yaitu dengan istilah IoT, Internet of Things. Di mana dengan Internet of Things ini kita bisa menghubungkan perangkat dan sistem untuk mengefektifkan, mengefisienkan peralatan-peralatan yang kita punyai, dan tentu itu akan berakibat kepada adanya efisiensi di bidang energi. Nah, dengan mempergunakan smart home, ya, smart campus, smart building, dan sebagainya, maka pengaturan pencahayaan, pengaturan energi itu akan mudah dilakukan dengan mempergunakan Internet of Things. Dan disitulah pentingnya kenapa Internet of Things ini menjadi fokus ya penelitian dan riset ya para akademisi ataupun mahasiswa belakangan ini. Nah, tentu banyak isu ya yang tidak sederhana ya di dalam menerapkan Internet of Things ini. Sebab kita tentu harus mempertimbangkan faktor ekonomi, ya, faktor keamanan, dan faktor kesanggupan kita di dalam mengoperasikan. Dan itulah yang akan sebagiannya nanti mungkin akan disampaikan oleh pembicara kita pada pagi hari ini. Nah, sedikit tentang pembicara kita ini, Mr. Cherin. Beliau ini adalah teman ya dengan saya ketika kuliah di S3 di Murdoch University di Australia dulu. Ya. Lumayan lama ini kebersamaan kami ya, dan beliau memang fokus risetnya tentang energy saving dan kemudian tentang Internet of Things. Ya. Dan jadi sangat beralasan ya, beliau kita kasih tugas nih pada hari ini, Mr. Cherin, to deliver the topic about Internet of Things, the potential tool for energy saving. Oke, mungkin itu saja ya, tanpa basa-basi lagi, marilah kita dengarkan pembicaraan ataupun materi yang disampaikan oleh Mr. Cherin ini. Oh iya, saat ini beliau ini adalah dosen di School of Computing di University Utara Malaysia, UUM. Dan UUM ini saat ini sedang berproses ya untuk kerjasama dengan FST Unja. Kemarin waktu akreditasi saya sudah declare tuh ya bahwa kita dalam proses ya on the way kerjasama dengan University Utara Malaysia. Mudah-mudahan kerjasama ini akan berlangsung ya. Jadi kegiatan kita pagi ini bukan kegiatan yang terakhir, akan ada serial berikutnya. Masih ada teman di sana seperti Pak Hisam ya, beliau ahli di bidang multimedia untuk orang buta ya. Nah, nanti pada kesempatan yang akan datang kita akan undang beliau juga untuk berbicara di di webinar kita. Demikian, dengan mengucapkan Bismillahirrahmanirrahim, maka saya membuka acara kuliah umum kita pada hari ini secara resmi. Oke. Baik, terima kasih. Oh ya, sebelumnya terima kasih kepada para panitia ya, yang sudah bekerja keras untuk mewujudkan acara ini. Prodi, kemudian mahasiswa ya, yang keren sekali menurut saya bisa menampilkan acara pagi hari ini secara teknologi. Selamat berkuliah umum. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Bapak Dr. Andes Jeffrey Marzal, kata sambutan yang memasuki ranah acara yang kita tunggu-tunggu. Penyampaian materi kuliah umum dengan tema Energy Saving IoT yang pada kesempatan kali ini akan dipandu oleh moderator kita, Zikri Hanafi dan Robi Siahan. Kepada moderator dipersilakan.
The much awaited event will be delivery of the 2023 public lecture material with the term Energy Saving IoT. Our moderators, Zikri Hanafi and Robi Siahan, will guide us through this session.
All right, thank you very much, Sri and Kairin. Good morning, everyone, ladies and gentlemen, and respected members of the audience. It is my pleasure to welcome you all to the public lecture on the topic of energy saving and IoT with Mr. Swanit Kerinchit, who is a major in School of Computing at the University of Utara, Malaysia. Today's public lecture is held on the month of Ramadan here at Jambi University. We are also live on YouTube and Zoom. I'm Zikri, your moderator, with my friend here, my partner, Robbie. I'm delighted to announce that we have attendance today, the Dean of Faculty of Science and Technology, Mr. Jeffrey, and docents who are study program of System Information 2021 and 2020. And of course, all of the participants who attend via Zoom meeting and those who are watching live on YouTube who come from different backgrounds and instances. Thank you all for showing your support today. Moving on, I'm gonna introduce to you Mr. Swanit. Mr. Swanit is an expert in the field of energy saving and IoT, but not just that. He also published several research papers and articles about this topic. We also are privileged to have him here to share his expertise with us. So, Mr. Chirin, are you excited to be here today and share your knowledge with us?
Yes, definitely. Definitely. It's a pleasure to be here with you all this morning. And I hope that you will enjoy the session with me today.
That's great to hear, sir. We are eager to learn from you. So maybe can you tell us a bit about your background and how you become interested in this field?
All right. Thank you, Zikri, for this session. All right. My interest, on IT actually started off in 1999, when I was a student in University of Utara, Malaysia. And in 1999, probably you haven't heard of what is IoT, You haven't heard what is Wi-Fi, But in 1999, that was the very first time when I got my first mobile phone, And one of the biggest problems we face when you get your mobile phone is that the burden of charging your phone every day. So that sparked my interest. So when I actually went on to Queensland University and later on to Murdoch University, I realized that there's actually a huge potential of research, in relation to energy conservation in mobile phones. And from there on, together with Dr. Jeffrey, we actually did our PhD together, and that was a time, during lunch especially, we would discuss about our work. So Jeffrey was looking into his 3D museum problem. I was looking into energy conservation. And during this short period of an hour or so, this is where we actually get some ideas and then, try to work on our solutions. And upon returning to Malaysia, I actually started off with becoming a fellow under the Internet Works Research Lab, IRL, where I am actually a principal researcher. And in 2015, I was actually offered a position to look into IoT deployment in University of Utara, Malaysia. And that was when I started to tinker around with Zigbee, started to tinker around with so many things, Arduino and all these kind of things, where we actually went on to develop several applications in relations to IoT as well. And though we have so many things developed, my interest still lies very, very much with energy conservation. And since 2012 until today, my interest has been energy conservation, looking basically into how we can actually play our part in ensuring that energy is actually conserved. Not only in mobile devices, but in wearables, into smart automation, to look into smart homes, to look into smart manufacturing, to look into smart vehicles. The spectrum is actually wide, and it's just not limited to that. Okay, and yeah, I actually encourage you all to actually have a look at energy conservation as well.
Yeah, thank you for sharing with us, Mr. Churin. We really are here in Faculty of Science and Technology in University of Unja, are looking forward working together with you. We're also looking forward for your lecture today and the insights you will share with us with today's topic. Pleasant time with you, sir, for you to present. Thank you.
All right, guys, very good morning to Dr. Jeffrey, my respected Dean of the Faculty of Science and Technology, who's also my very good friend, who is also my very good brother. Thank you very much for inviting me to be part of this session today. To my brother, Zikri, thank you very much for the kind introduction. To our chairpersons, okay, very good morning. To the senior management of Faculty of Science and Technology, members of UNJA, to all the organizing committees, beloved students physically and also virtually. Very good morning. And again, thank you very much for making it today to this session on energy conservation and IoT. Okay, a little bit about myself. Okay, my name is Charin. Okay, and I am a lecturer with the School of Computing, University Utara, Malaysia. It's been 20 years here in UUM. Okay, I first started off as a tutor, and then becoming a lecturer. Okay, and then in 2005, right up to 2008, I was seconded to the International Telecommunications Union. Okay, looking into RICTD, rural ICT development. Okay, where I had the opportunity to travel extensively in many countries. Okay, in Southeast Asia, and I had the pleasure to visit many places in Indonesia to find the beautiful people, the beautiful faces and places, okay, as well as meeting wonderful people like Dr. Jeffrey. And then 2008, right up to 2012, okay, I was in Murdoch University, and upon returning to Malaysia, okay, I became the chairperson of community development, okay, with the Center of University Industry Collaboration Center in University Utara, Malaysia, before I was appointed as the deputy head for business development and community development in the School of Computing, University Utara, Malaysia. So I'm currently with the MCMC UUM Makerspace Lab, okay, where we look into Makers Initiative. Okay, I hope you all have Makers Initiative in Indonesia as well, where we do not only buy things. Okay, what we do is we develop things, 3D printing. Okay, we do our own circuits. We do all kind of things. Okay, from scratch. Okay, so I'll be talking about that a little bit later. Okay, so what happens today is that I'll be sharing with you, okay, some of my experiences in terms of energy conservation in mobile devices. Okay, and we'll be touching on a little bit on the IoT. Okay, so Zikri, okay, if I may actually share my screen with you so that I can proceed on with my presentation. Okay, so we shall start, okay, with our presentation today, okay, and the presentation is titled Energy Conservation in Mobile Devices, okay, and the Internet of Things. All right, so what happens in today's lecture is that, okay, I understand that it's only almost 9 o'clock in Indonesia, 10 o'clock here in Malaysia. It's pretty early in the morning, okay, and the topic that we'll be discussing would be a little bit highly technical, okay, and therefore I'll be going very, very slowly, okay, to ensure that you can understand what is being delivered, okay, and during this presentation, if you have any questions, just feel free to, alert the moderator, and you can actually share your questions with me, where I will be more than happy, okay, doing my best to answer your queries, okay. So this is a little bit on energy conservation in mobile devices, okay, and the Internet of Things, and I believe that this whole presentation should be no more than an hour. Okay, so let's start with our presentation. Okay, when we talk about mobile phones, okay, it's very best that we actually look into what or how, okay, mobile phones have actually evolved throughout the years. Okay, so that is to set off the dimension of our presentation today so that we understand what actually happens in 1973 right up to 2023, which is about 50 years ago. Okay, so if let's say we just go back 50 years ago to 1973, this is where we started off with mobile phone. Okay, so Martin Cooper from Motorola, he actually came up, okay, with a mobile phone, okay, in 1973. If you look at it, okay, it's not a really sophisticated phone. Okay, it's basically a phone, a battery-powered phone that allows you to speak only for a period of 30 minutes. Okay, and it's powered using batteries, and the batteries is so huge. Okay, and it costs you a lot. Okay, to basically get connected to a phone call, okay, and to make that phone call, okay, that is 1973. And this mobile phone, okay, is known as the brick, okay, batu bata. Okay, now let's move on 10 years later, okay, in 1983. In 1983, okay, the first mobile phone, okay, is actually commercialized. What happens here is that we have the Motorola Dynatec 8000X, okay, that is basically something that is much more portable. Okay, so if you can see here, okay, in 1983, when Dynatec was actually introduced, the battery lasted around 8 hours, okay, and weight, okay, the weight is about 28 ounces, okay. And then 1989, okay, what happens here is that we have the Microtech, okay. Microtech does not actually use a metal transmitter, but what it uses here is basically a receiver that is more of a plastic component, okay. What you can see here is that, okay, for the Microtech, is basically a prototype. It's not really a full-fledged mobile phone. However, it sets the trend, okay, of coming up with a much more functional mobile phone. Now, in 1990, okay, 17 years after the technology of mobile phone is introduced, okay, then the Japanese company Nippon Telegraph actually came up with a palm-sized phone, okay, something that is the size of my palm today, okay. However, okay, due to its small state, due to its small nature of the mobile phone, okay, battery capacity is limited, and you are only capable of making a call, okay, for no more than 45 minutes. Okay, now in 1999, okay, there is actually an evolution. Okay, something big actually happened in the mobile phone technology, is that we have the wireless application protocol introduced into your mobile phone. Okay, so this is where you can see, okay, a mobile phone which actually embeds wireless communication capabilities, okay, that actually pave ways, okay, for us to have multiple radio interfaces on our mobile phone, allowing us not only to make phone calls, but also to make, to actually go on the internet, to browse the webs, to browse, you know, the internet, so on and so forth. Okay, now 1999, okay, this is the Nokia 3210. Okay, so for those of you who have probably, yes, anyone? Okay, in 1999, okay, the Nokia 3210 was introduced. Okay, and for those of you who lived through this generation, Dr. Jeffrey, myself, and probably those of you, you know, who was already, you know, living in that era, 3210 was probably one of the most successful mobile phones around. Okay, and you still find it today. Okay, and today, okay, interestingly, there are actually many people who are actually shifting towards using a simple mobile phone, okay, as a Nokia 3210 again. The reason being so here is that, okay, we realized that during that time, okay, the power consumption of mobile phones, okay, is very low, okay, and we are only using basic features just to make a call, okay. Therefore, it allows us to actually look into increasing our productivity, simplicity of life, okay, and things that doesn't actually disrupt us so much. Okay, now in the year 2000, okay, what happens is that a mobile phone, okay, which actually embeds a camera is introduced. Okay, so back in the early 1990s, okay, back in the 2000, you don't actually go around taking pictures, okay, your selfie pictures, so on and so forth. Basically, if I do remember well, okay, in 1999, in the year 2000, the only thing that I do with my mobile phone back then was basically to make a call to my mother, to make a call to my father and my friends, okay, and at any different time, okay, basically is to play the snake game on your mobile phone. The functionality is very, very, very little. Okay, now in 2007, okay, the first iPhone was actually introduced. Okay, as you can see here, okay, it was a revolution in terms of how we come, okay, in terms of mobile phone technology. Not only do we embed the capabilities of mobile telephony, not only do we embed the capabilities of wireless application protocol, but you can see here the introduction of an iPhone basically changes how the game is played. What happens here is that with iPhone, you can make a call, you can message, you can text, okay, you can play games, but also there is an introduction of high resolution camera. There's also multimedia elements in that. You have sort of like a a music player, you actually have a video player, so on and so forth. Okay, in 2010, okay, what happens here in 2010 is that the introduction of a 4G phone, which means that, okay, not only the needs of processing is greater now, okay, what we are interested here is that we want faster data transmission in terms of your mobile phone, when you actually use your mobile phone, okay? And if let's say we move forward to 2023 today, your mobile phone is not just a communication device anymore, okay? It is actually a myriad of applications, okay? If we could just list down, it makes calls, it is actually a tool for you to communicate, it is also your personal assistant, your calendar, so on and so forth. It's a communication tool, email, social media. It's also your entertainment tool. You play music, you play games, you watch movies. It's also a health, okay, a health application where, for instance, okay, my phone tells me how much calorie I burn in a day, how far do I walk in a day. If I actually put in some data, it basically tells me what is my calorie intake, okay, how much calories should I burn, so on and so forth. So you can see here, okay, a mobile phone today is not just limited to a communication tool, basically, but what happens here is that, okay, it is actually what you can see around you all crammed up in one simple device, okay? And if you look into all that, okay, the evolution of mobile phone, okay, in 1973, it used to be something that is so huge, okay? Reason being so is that the components of a mobile phone, okay, the microelectronics, the battery, they are all still very huge, okay? So it has, okay, so it was big, okay? And then if you look into 1989, 1990, okay, things are all miniaturized. We try to live up to the notion of mobile, okay? So everything has to be very small. It was a flip phone, okay, a phone the size of your palm, okay? But if you look back, okay, look back into the 2007 and so on and so forth, okay, mobile phones tend to be very big again, okay? There was once, okay, people were talking on their PDAs, people were just talking onto their iPads, mini iPads, so on and so forth, okay? The reason being so is that we try to actually look into higher processing power, better display, at the same time, more power requirements, okay? But thankfully, okay, the trend is now shifting back to more miniaturized design, okay, better resolution, better voice quality, better video quality, okay, at the same time, it is lightweight, okay? So it's no surprise today, if you just look around, okay, mobile phones now come in a standard, okay, easy to carry size, okay, with very high processing power, very high video resolution, okay, to meet the requirements of users today. So you get to see here, okay, the evolution of mobile phones today. So what is the status quo of mobile phones today? Okay, based on the statistics, okay, by statista.com, okay, in 2021, it is estimated that we have about 14 billion devices, okay? Of these 14 billion devices, okay, close to 6.4 billion devices are actually mobile phones, okay? 1.7 billion, okay, are basically tablets, okay? However, there are still 4.4 billion people around the world, okay, who are just basically using simple mobile phones, okay, basic feature phones. And this is basically rampant, okay, especially in countries where people are poor, people are not very well connected, okay, people who basically just don't require, okay, sophisticated devices on the day-to-day living, okay. So they still have about 4.4 billion basic feature phones, okay. And today, okay, let's just have a look around, you know, your friends in the lecture hall, okay, those are sitting next to you. How many of them actually have a smartwatch? Okay, a watch that basically lets you play music, lets you receive SMS messages, lets you receive WhatsApp messages, lets you do simple transaction. Okay, so these are all wearables. Okay, for example, okay, people nowadays, okay, put on their watches, you try to see, okay, how many hours do they sleep, how many hours do they actually, you know, go into deep sleep, how many hours do they get stressed, how many hours do they actually work out, so on and so forth. So basically, what is happening around the world today is that people are quantifying their life. Everything has to be in numbers, okay, because people are concerned about what life is all about, okay. And other things, okay, other than just mobile phones, tablets, so on and so forth, we also have other connected devices, okay, which is amounted to about 1.1 billion, okay. And this is where, okay, we can see a lot of IoT technology being actually deployed, okay. So we have things like smart home, okay, smart offices, okay, where we can basically control appliances, okay, that actually, you know, that we can do our daily lives activities, okay, basically by controlling all these smart appliances that we actually have, okay. And this is, my friends, okay, in 2021. Today is the first quarter of 2023, and I believe that the numbers have actually gone up to more than 15 billion today. Okay, we do actually see that more and more people are getting their mobile phones due to the economy of scale. Okay, more and more people can now buy their mobile phones. Okay, more and more people are using tablets. Okay, and of course, more and more people are using wearables. Okay, so this is the status quo. Okay, basically, this tells us the number of devices that we currently have today. Okay, now, when we talk about all these devices that we are using, okay, one thing that strikes our mind here is that how much carbon footprint is generated per device. Okay, so when we look into a mobile phone, from the moment a mobile phone is being produced to the moment a mobile phone is deemed to be no longer in use, expired, okay, we basically use an estimated of 55 kilogram of CO2, 55 kilogram of carbon dioxide. Okay, where does it come from? Okay, from the moment, okay, you decide to design a mobile phone, okay, from the moment you put in a new circuit, from the moment that you actually mine for all the elements, okay, right up to the processing, okay, and then from the moment that you actually purchase a mobile phone, okay, you use it to send messages, you use it to basically browse the internet, play your games. That requires basically for you to get connected to the internet, get connected to your power source, okay, which comes from hydroelectric dams, which comes from coal, which comes from all sources of energy, okay, that allows you to charge your mobile phone right up to the moment where your mobile phone is no longer in use and it needs to be basically recycled or disposed of. Okay, you basically use about 55 kilograms of carbon dioxide. Okay, now what you can do with this is that, okay, try to take 55 kilogram and multiply it with 14 billion devices. That is a really huge number, and it's really putting on a lot of environmental impact on our lives today. So what is most important today here is that we need to find a solution to make sure that, okay, our environment, okay, can actually be conserved. We need to make sure that our future generation can live in a very good environment, okay. And what we can do here is that we need to ensure that efforts are being taken to make sure that energy conservation, okay, is done. we are not trying to solve the world's problem, but what we are trying to do here is that we are trying to address one problem, one small problem, okay, through one particular solution. Okay, so that is how problematic, okay, the usage of mobile phones is impacting our environment today. All right, so if you are not, okay, for you all to be able to understand, okay, a little bit about mobile phones, okay, so this is actually the breakup of a typical iPhone, okay, and of course will not be going through everything, okay, on this mobile phone, okay, but it is actually important, okay, it's imperative on my side, okay, to tell you the major components of a mobile phone, okay, and where the biggest consumption of energy actually happens. Okay, so this is an iPhone, okay, as you can see, this is our power module, okay, basically this is our battery, okay, and this battery, okay, is basically a lithium-ion battery. Okay, you can see here is lithium-ion battery, which actually provides a limited amount of energy, okay, over a period of time, okay, and it allows us to power our mobile phone to do the processing, to do the communication, to do the display, okay, and of course to do a myriad of activities such as the internal clock, okay, which basically operates our mobile phone, okay, and based on our usage pattern, okay, the power module will deplete over time, okay, and you need to recharge it again. All right. The brain of our mobile phone is the processing module. Okay, we have two things here. One is of course your CPU, okay, your processing unit, and then with modern mobile phones today, we also have the graphical processing unit. Okay, the higher the resolution, the higher the processing, okay, the more power is required by your processing module. Okay, if you look into this part of your phone, okay, as well as the lower part of your phone, this is where your communication module is. Okay, so if you look here, this is where your SIM card is. Okay, this is basically your 3G, your 4G, to some mobile phone today, okay, it's your 5G component, which allows you to collect through the cellular network. All right, and on this side, okay, is where you have your Bluetooth, is where you have your Wi-Fi, okay, and as what is most important that needs to be addressed here is that the requirements, the power requirements of all this communication module may differ. Okay, Wi-Fi will actually consume more power, but the transfer speed, okay, between in a Wi-Fi is much more higher compared to a Bluetooth device, which consumes less power, but the speed is very, very low. Okay, so we will be looking into this later in my lecture, okay, of understanding what is actually an energy cost. Okay, and of course, okay, you, me, and everyone else in this room today, we cannot live with our camera. Okay, you get up early in the morning, okay, you just turn on your camera, send a picture to your friend, send a picture to your mom. Good morning, mama. Good morning, papa. Whatever. Okay. When you buy food, okay, before you eat the food, take a picture, okay, with your camera, and then you send it to your friends. So this has actually become an important element in our lives today. Okay, so basically all these, okay, all these components are actually components that contributes, okay, to how we consume energy in our daily life. All right, so okay, so we have seen here, okay, the evolution of mobile phone. Okay, we have seen the amount of energy that is consumed by one mobile phone. Okay, we have also seen, okay, the different components of a mobile phone. So one question that actually strikes our mind here is that, okay, what happens to all this mobile phone? Okay, so there are four things, okay, that we can look into. First of all, okay, if you look into your mobile phone again, okay, today mobile phones is just not a communication tool. Mobile phone is actually a productivity tool. Okay, you can make simple application. You can use simple applications such as your PowerPoint, such as your Google Docs. Okay, it's a productivity tool. Okay, it's also a communication tool. Email, Skype, WhatsApp, Line. Okay, just to name a few. Okay, You also have your games. Okay, I bet most of you are actually playing your Mobile Legends. Most of you are playing all kinds of game, your Candy Crushes and all that. Okay, it's also some of you actually watch your Netflix on your mobile phones, so on and so forth. Okay, so what you can see here is that mobile phones basically is just not a tool for you to call your friends anymore, but it's all basically a myriad of applications that you use in your daily life. Okay, and as a result of that, a mobile phone, a mobile device, basically needs high processing power. Okay, now if you look into your mobile phone again, your mobile phone is not just, or your mobile device, it's not just a tool for you to make your phone call only. If I look into my mobile phone now, there is actually no less than 3 different radio interfaces. What does it mean by radio interfaces? So you have Bluetooth. Bluetooth is one radio interface. Wi-Fi is another radio interface. Cellular network, 3G, 4G, 5G is also another radio interface. So when you actually have all these radio interfaces in one place, then what happens here is that your mobile device now consumes more power. Look into Wi-Fi. If you look into Wi-Fi, 2.4 gigahertz running on the industrial and scientific medical band, is an open network. So if you're running on 2.4 gigahertz, it means here is that your data has to be compacted and sent across the network. What happens here is that you are capable of transferring over about 100 meters. And after that, after that 100 meters, what happens here is that you are continuously asking for a retransmission, and that retransmission due to packet loss, due to interference, so on and so forth, and that actually impacts the power consumption. If you're talking about a 2G phone, GPRS, if you're talking about a 3G phone, where you can actually make a call, for far away. If you understand the concept of physics, V equals to F lambda. V is the speed of network, the speed of your data. F is your frequency, and V equals to F lambda. Lambda is the length of your signal. So if let's say, V, the speed of your data is a constant 330 meters per second. If your frequency is high, 2.4 gigahertz, 5 gigahertz, that actually says that, the length of your signal is very, very short. That is why if you're using applications such as 2G, 2.4 gigahertz, IEEE 802.11, ABNG, or if you're using 5G telephone, 5G network, you will notice that, you will not be able to transfer over a long distance. But if you're talking about Telegram, if you're talking about not the application Telegram, what I mean, Morse code, for example, or normal telephone, what you can do is that you can transfer over a long distance, basically because of the short, the low frequency and the long, the length of your signal. That is why mobile phones can allow you to make calls, over a long distance, Now, the third problem here is that, we all have limited battery capacity. So over the years, over more than 21 years, me working on battery technology, we have come across so many different types of technology. We used to have basically a use once battery. Basically, you use it and then you just discard it. Today, we also have rechargeable batteries, which allows you to use your battery over and over again. And of course, one of the biggest challenges when it comes to mobile devices here is that we are so addicted, we are so used to using our mobile phone. I can take a bet over here. The first thing you do when you get up early in the morning, is to switch on your mobile phone. Some of you actually sleep with your mobile phone on. So for instance, for myself, the moment I open my eyes, the next thing is that I start to switch on my mobile phone, to see if there are actually incoming messages, so on and so forth. Then while you're doing your nature's business, okay, you're seated in your toilet, you browse the news, you look into Twitter, you look into Facebook, you look into Instagram, you look into all these social media, okay, just to keep yourself updated, okay? So the more hours you spend on your mobile phone basically translates to the more energy that is consumed. So these 4 different challenges basically outlines, okay, how we need to solve problems in terms of energy conservation, okay? So as I mentioned earlier, okay, since 2012, okay, I've been working on solutions for conserving energy in mobile devices. Okay, so if you look here, okay, there are 3 different fronts that we can use, okay, in terms of addressing this problem. The first front is by hardware approach, okay, and then we look into network protocols. Okay, my focus is basically on network protocols, okay, and of course we have the third one, which is software. Okay, so for the next 20 minutes or so, I'll be sharing with you what can we do from the hardware perspective, what can we do in terms of the network protocols, and what can we do from the software protocol, software perspective. Okay, so for the time being, okay, is there any question that you'd like to ask? That's none, huh? Okay, so the next few slides, okay, will be a little bit technical in sense of you will require certain understanding, okay, of how we deal with hardware, network, as well as software approaches, okay, in conserving energy. All right, the first one, okay, is hardware. Okay, so when we talk about hardware, okay, basically here we are talking about the radio interfaces. Okay, we are talking here about Wi-Fi, we are talking here about cellular network, we are talking here about Bluetooth. Okay, we are also talking about things like our screen, we are talking things like our processor. Okay, so the first thing here is that we look into our radio interfaces. Okay, the first thing you got to know, okay, with regards to your radio interfaces is that, okay, your phone, okay, or your laptop or your tablet or even your watch, okay, it does not stay in active state all the time. Okay, instead, okay, you will notice that, okay, or you need to know that, okay, there are actually 4 different states when it involves the radio interfaces. Okay, so in this diagram, okay, it's shown 3, okay, because off means you off everything. Okay, so the first state here is an active state. Okay, this is an active state. So what is an active state? During an active state, okay, be it Wi-Fi, be it Bluetooth, or be it cellular network, okay, your interface, your radio interface, okay, basically listens to incoming messages. Okay, so let me just give you an example. I am now presenting to you, okay, a presentation about power conservation. I'm not using my phone basically, okay, but during this period of time, okay, my phone, okay, for every 5 milliseconds sends a message to the nearest base station to actually inform the base station where I am currently. 5 milliseconds. Okay, so when it sends the message from the phone, from your mobile device to your base station, and then the base station responds, there is actually an interaction between these devices. Okay, so this is what we call as an active state. Okay, and during this active state, we are listening. Okay, at the same time, okay, if let's say I am now seated in my office, I am texting away, I'm watching a video, or I'm on social media, then what happens here is that I am actively transmitting data. Okay, so active listening, actively transmitting data consumes the highest power of consumption. Okay, so that is my active state. Okay, next one is that, okay, now you imagine, okay, you finish class, you finish work, okay, and you're driving back home, okay, or you're seated in a train, you're seated in a bus, okay, just waiting to get home. Okay, you're not engaged in any communication, you're not texting, you're not listening to music, you're not on social media, so on and so forth. Okay, during this time, your mobile phone is still listening. Okay, as what I mentioned earlier, it's listening to incoming calls, in listening to incoming messages, actively engaging with the base station. Okay. During this time, however, okay, there is passive data transmission, which means that you are not engaged in any communication at all, hence the low power consumption. Okay. Now, there is some time, okay, there is a time when you're not doing anything at all, nothing at all. Okay. Basically, your mobile phone is only on, okay, is only on for internal clock activities. So you are listening, okay, very little data transmission, okay, and this actually uses the lowest power consumption. What is an instance? What is an example, okay, of a sleep state? A sleep state is when you turn off your mobile phone, you turn off all your mobile devices, okay, except for your phone, okay. So that is to allow you to receive phone calls at night. That's the simplest thing you can do, okay. During this time, okay, there is no or very little data transmission, okay, and therefore, okay, it has the lowest power consumption, okay. So when you understand the power regulation of your mobile phone, then there are many ways, there are many approaches that you can use in terms of conserving power. Okay, so one of the solution here is that, okay, one of the solution here is hardware, okay, and this is basically in terms of your radio interface regulation, okay. So this is actually introduced, okay, this is actually introduced in the mobile device, okay, introduced in a laptop, okay, in a laptop many years ago, okay, where we try, okay, to reduce the power consumption of a laptop. Probably Dr. Jeffrey, probably to our friends who are from the later generation, okay, from the older generation, there was a time in life, okay, where we actually have our CD player, okay, in our laptop. Okay, if you do remember, okay, when you are actually running your laptop with your CD on, okay, you can actually see the spinning, okay, the CD actually goes spinning in your laptop. At certain times, it goes on a very high speed. Okay, what happens here is that it's reading, okay, and that particular high speed basically consumes a lot of power. But when you're not doing anything, okay, the CD is still in, the CD will stop reading. What it means here is that, okay, if I notice that you're not doing anything, then we might as well rest, we might as well sleep. That is how we basically reduce power in our laptop or our mobile devices, okay. To some of us here today, okay, if you just switch on your laptop, if you just walk away from your laptop for a minute or for probably half an hour or so, then your screen goes blank, okay. It just turns off. So that is actually what we can do in terms of trying to reduce the energy consumption by switching off our screen. Okay, there are many ways, okay, where we can actually deal in terms of hardware. Okay, now this is where, okay, I started to have interest in terms of what I'm doing today with regards to energy consumption. Okay, battery technologies. Okay, so these are examples. Okay, these are examples of how, okay, we have done or what we have done, okay, in terms of battery usages, okay, in our mobile devices. So the most commonly used battery, okay, is the lithium-ion battery. Okay, I have mentioned it earlier in my presentation. A mobile phone, for example, an iPhone, okay, it has a lithium-ion battery. Okay, so what are the characteristics of a lithium-ion? It is lightweight. Okay, that means that is to suit, okay, a mobile device. Okay, it has high energy density, which means that for a very small pack of battery, it has a lot of power in it. Okay, and of course, it is rechargeable. Another one is known as the LiPo or lithium polymer. Okay, just like the lithium ion is lightweight. Okay, but of course, what you can see here, it has higher energy density and it is rechargeable. Okay, many years ago, okay, we have this thing called the nickel cadmium or NiCad battery. Okay, NiCad has very low energy capacity, energy density. Okay, however, the problem here is not about its energy density, but what we can see here is that it has very high level of toxicity, which means that it actually pollutes the environment more when you actually use a nickel cadmium. Okay, due to that particular reason, nickel cadmium has now been phased out in terms of battery technologies. Okay, a solution to nickel cadmium, okay, is what we call as nickel metal hydride. Okay, similar to nickel cadmium, but less in terms of toxicity. Okay, if you're talking about today's mobile phone, okay, I do not know what is the latest model today, okay, but I've seen some advertisements going on TV. Okay, it is said that some mobile phones today allow you to charge from 0 to 100 in less than 45 minutes. Okay, this is known as the fast charging technology. Okay, and what you can see here is that, okay, yes, fast charging technology basically reduces the burden of charging your phone. However, it does not really address the problem in terms of energy conservation, does not actually address the problem of environmental problem. Okay, so we can charge over a shorter period of time, that is true, but still the energy demand, but still the environmental impact, okay, generated by mobile phones is still a huge problem. Okay. Another solution in terms of battery, okay, is the solid state battery. So you have heard about chemical batteries, so on and so forth, okay? But in a solid state battery, basically we use electrolyte, okay, which means that it is much more compact, it has a very high energy density, okay, and it allows you to use your mobile phone, it allows you to use your mobile devices over a very long period of time, okay? This, however, is still in research. Okay, another approach, okay, related to energy, okay, is nuclear powered battery. Okay, but of course, okay, this initiative, okay, is kept only at its research state because nobody would want to put, okay, a nuclear powered device so close to your brain, so close to your ears. Okay, it could bring you health impact over the long period of time. Okay, and this is not something that is basically feasible at all. Okay, so these are examples of hardware solutions. Okay, when it comes to how do we actually power our mobile devices. All right, the next one, okay, is about our display. Okay, so if you're talking about an iPhone, okay, you're talking about your iPhone today, okay, what you can do here is that, okay, you can adjust your brightness. You want it to be bright, you want it to be less bright, you want it to be dim, okay? The brighter your mobile phone, the more energy it consumes. The lower the brightness, the lesser energy it consumes, okay? That is the simplest sense that you can actually make out of it, okay? If you look into our screen technologies today, okay, we have come with so many different types of display screens that we have now. Okay, many years ago, okay, probably the time when Dr. Jeffrey and I first met, okay, in 2010, 2008, 2009. Okay, most of the phones are basically liquid crystal display. Okay, so basically what is being used here is that, okay, we use liquid, okay, and that when power is actually being supplied to your device, okay, it lights up the display, and this basically allows us to see, okay, our screen to light up, and we basically can see the display is on that. Okay, but as you can see here, liquid crystal display, okay, it consumes more energy. Okay, at the same time, the liquid crystal display, the liquid, okay, it actually poses some environmental hazard, okay, in terms of in the long run. What we have nowadays, okay, we have the OLED display. Okay, as you can see here, OLED display, AMOLED display now comes in full screen. Okay, what is more interesting here is that the energy consumed, okay, by all these devices, okay, are lesser due to the fact that, okay, we are not using liquid crystal anymore. We are just using LED. Okay, and as you can today, okay, most displays are AMOLED display, and this basically uses very little power. Okay, next thing here is that, okay, if you look into mobile devices today, okay, there is an actually option where you can actually do your dark mode. Okay, so instead of having a white background screen, what you have is a black background screen over white color text. Okay, and that in another way actually allows us to reduce power consumption. Okay. Of course, as I mentioned earlier, okay, when you're not using your laptop, excuse me, when you're not using your laptop, you're not actively engaging in any activities, automatically over a certain period of time, your screen will turn off. So that is what we call as reduce your timeout. Some of us choose to reduce your timeout, okay, after 30 seconds. Some of you decide to use reduce timeout after a minute. Some of us after 10 minutes, some of us after 30 minutes. All this is up to you as a user on how you want to reduce or how you want to conserve power in your mobile devices. Okay, to those of you who are always engaging in playing games, always engaging in watching movies, always engaging in social media, chats, and so on and so forth, okay, and you compare it to somebody who basically don't use it for anything except for texting and making calls, you will notice that, okay, the energy consumption of the other person is basically very, very low. The reason being so here is that, okay, each time you have animations, each time you have graphic display, each time you have new things being fed into your screen, okay, it needs to be refreshed all the time. This refresh procedure basically consumes a lot of energy. So by turning off animations, basically will allow you to reduce your energy consumption. Okay, so that is in terms of the hardware. All right, so that is on the hardware side of your energy conservation. Okay, what will happen here is that, okay, you will be looking into some of the work that I have been carrying out, okay, over this past 11, 12 years, okay, in terms of addressing power consumption through network protocols. Okay, so before we go into that, okay, I'll be only talking about two protocols here. There are many protocols basically. Okay, the first one is known as the TCP wake up. Okay, so to those of you who are not familiar, TCP is the transmission control protocol, okay, or transport control protocol, which allows you, which basically says that, okay, how we transmit data, okay, through the network. Okay, so let's just go back to a little bit on TCP, okay, and focusing specifically on IEEE 802.11, which is on the Wi-Fi protocol. Okay, so let me just walk through, okay, this whole process of 802.11 Wi-Fi. Okay, so if let's say, okay, you have a device, okay, a mobile phone, and you try to connect to your mobile phone through Wi-Fi. Okay, so what happens here is that when you turn on the Wi-Fi interface, okay, what happens here is that your mobile phone will associate the device to the nearest access point. Okay, so there is an association where they exchange, okay, messages. Okay, it allows you to establish a connection and data transfer to basically take place. Okay, so if let's say, okay, during the particular period of time, there's an active transfer from your mobile device to the access point, or from the access point to your mobile device, okay, then your mobile phone or your mobile device, okay, will shift to an active state where active transfer actually happens. Okay, now when there is no active connection happening, okay, then your mobile device will know that, okay, I'm not doing anything, I better conserve my energy by going into either idle state or sleep state. Okay, so we try to reduce energy consumption. But during this period, what happens here is that your mobile device will switch on periodically, okay, to listen for incoming messages. The wake up and then sleep, wake up and then sleep. Okay, so the first question here is that how frequent should we wake up, or how frequent should we sleep? Okay, in one study that is actually carried out, the process of waking up actually consumes as much power as an active transmission, just to wake up and to sleep, okay, because of the powering up activity. So we can see here that constantly waking up, sleeping, the duty cycle actually consumes high amount of power. Okay, so what do we do from this? So what happens here is that we introduce TCP wake up. Okay, so in TCP wake up, okay, specifically looking into IEEE 802.11, which is Wi-Fi, we tell that, okay, fine, okay, we need to wake up over a period of time. So we try to keep a mobile device in a sleep state or an idle state for as long as possible, only to wake up when it is required. Okay, so that is the first concept that we are trying to introduce here. So how does this actually work? All right, so when a mobile device, okay, goes into a state, idle, active, or either sleep state, okay, it actually tells the mobile, the access point that, hey, okay, I'm going into this state, okay, I'm sending you a small message, a wake up message, to tell you that, okay, if I'm not doing anything, I'm switching off my primary interface, which is my Wi-Fi. So in this time, okay, I will only turn on my wake up receive, okay, to receive messages. So, okay, it's a switch here. I turn off everything except for one interface, okay, which is the wake up receive turn on. So this basically says that I don't have to do anything. My Wi-Fi interface need not do anything. I'll go to sleep state and I only wake up, okay, if there is an incoming message to wake me up. Okay, now, if let's assume that at this particular period of time, okay, a message actually arrives. So what happens here is that, okay, when the message actually arrives, it turns off the receive interface, but your primary interface, which is your Wi-Fi, is then turned on. So this is actually a very simple concept where, okay, if you're not doing anything, you go to sleep. If you need to do something, you stay awake. Okay, so this concept is actually being adapted, okay, from the earlier concept of human biological process. If you are tired, if you're not doing anything, you rest. Okay, if you need to work, then only you perform certain activities. So this is TCP wake up. Okay, so extending from the work of TCP wake up, what we do now is that, okay, we have this wireless interface activation. Okay, this is actually my PhD work, okay, abbreviated as VINA. Okay, so what VINA does is that, okay, if you look into TCP wake up, it basically looks into Wi-Fi interface, but in VINA, we are basically looking into all radio interfaces on a mobile phone. It can be cellular network, it can be Wi-Fi network, it can be Bluetooth network, it can be infrared network if you have it. Okay, so how does this actually work? So what happens in VINA is that, okay, we still keep the protocol simple, mobile phone and access point. But the difference here is that, okay, we introduce this VINA receiver and the VINA transmitter, or we call it the auxiliary devices. Okay, so what happens here is that, okay, what happens here is that, assuming that my mobile phone is switched on at the moment, okay, it can be active, it can be idle, it can be in a sleep mode. Okay, now, if let's say my mobile phone is not doing anything at all, there is no data transmission, no active communication. So what happens here is that, okay, the access point, or what we call as the base station, will send a message to the VINA transmitter. Okay, so VINA transmitter will send a message, okay, to your VINA receiver to say that, okay, hey, okay, your device is now idle. Okay, do you want to switch it off? Okay, so VINA receiver will then check with your mobile phone, okay, if it is active or it is idle or it is sleeping. So if let's say it is idle, okay, so what happens here is that VINA transmitter broadcasts service presence to mobile phones. Okay, now the mobile phone will receive the particular message. It looks into its state. Am I active? Am I idle? Or am I sleeping? Okay, so if let's say, okay, let's say it receives a message from the VINA receiver, it switches on all relevant devices. Okay, and then it broadcasts a message and associates to the points of access. Okay, so the operating system will record all present and non-present wireless network. Okay, now the mobile phone, the mobile device knows that it's not doing anything, so it switches off everything. This is where the VNA receiver and the VNA transmitter plays its role. Okay, now all interfaces are switched off. Okay, only the VNA receiver monitors the incoming call. Okay, at that time, if let's say there is a call, a cellular phone call, a voice over IP call, a message, a WhatsApp message, or so on and so forth. Okay, if it actually arrives at the point of access, okay, the point of access will inform the VNA transmitter that, okay, a message has particularly arrived. What message? It can be a cellular network call, it can be a cellular network message, it can be a Wi-Fi message, it can be a Bluetooth message, so on and so forth. So VNA receiver will receive the message from the VNA transmitter, and it only inform the mobile device to turn on the relevant interfaces. So if it's only for Wi-Fi, then we don't turn on your Bluetooth, we don't turn on your cellular network. We only turn on one particular interface and let that transfer actually happens. Okay, so when that particular process happens, then they transfer data as required. After that has completed, okay, it will stop all communication, okay, and it stops the communication, and the mobile phone will again go back to its earlier state of either idle or sleeping. Okay, so you can see here what happens here is that number one, okay, the contribution of the research here is that we are introducing a VNA transmitter and a VNA receiver, which basically uses very, very simple 3-bit packet, which basically says that which interface to turn on, okay, the flag to turn off, okay, and basically the end of our particular process. Okay, so it's only a 3-bit. So if let's say you have 2 times 2 times 2, basically you're looking into an 8 radio interface process. Okay, 8 radio interface on a particular device, which is actually more than the interfaces, okay, that we actually have today. But okay, but this is to look into the future when we actually have different types of network technologies, and therefore, okay, we have actually come up with a different 3-bit protocol. Another contribution here is that, okay, we only turn on what is necessary. Okay, so you do not have to basically go all the way through the process of associating, disassociating, so on and so forth. So we all know through the VNA transmitter, the VNA receiver, okay, where is your location, which is your access point, and the moment that you are actually active, then data transmission is allowed. Okay, we have done simulation in terms of this particular protocol, okay, and through this particular protocol, we are able to conserve energy of up to 120%, which is double of the amount of energy, okay, that we can actually save in a day. So that is a little bit on VNA. All right. Next one, okay, next one is to look into software optimization. Okay, we look into code optimization. So to those of you who are software engineers, you are all into AI and so on and so forth. Okay, we look into code optimization in terms of we try to reduce the number of if, else, do, while, so on and so forth. Okay, each time you try to basically look into these conditions, okay, it requires a little bit of processing, and that will result in terms of more power being actually used. Okay, if you look into your mobile device today, okay, your iPhone has power management, your Windows has power management. Okay, so basically you can customize, okay, how power management settings are being done. Okay, it reduces performance when battery level drops below a certain threshold. Okay, if you look into your mobile phone today, okay, the moment your battery actually reaches a threshold of 20%, okay, you will notice that, okay, not only is the performance of your mobile phone reduced, what happens here also is that your network speed is reduced. Okay, that is number one. Second thing here is that, okay, if you look into your battery, okay, if you're using your mobile phone, you're playing your games, you're looking into browsing, you're doing something, okay, the moment it reaches 20%, you will notice that your mobile phone, your mobile devices basically heats up, okay. The heating up of your mobile phone or your mobile device is basically an indicator that more power will be consumed, okay, through heat dissipation. So the best thing you can do then is that, okay, to plug into your phone or basically just to switch off or reduce your activity. Okay, that is power management. Next thing is background processing. Minimize the amount of processing done in the background or only run background tasks when device is charging. Okay, this is very common. Okay, this is very common, especially when you try to deal with software updates. Okay, it basically tells you if you are not using your power, okay, if you're not charging your your devices, then your update will not happen. You can charge it later of the day, okay, when everything else is not being conducted, or you can charge it now, but with the requirement that if your devices are basically being charged. Okay, we can also use software, okay, to control network usage. Okay, basically is to minimize the amount of data transferred, reduce the frequency of requests, okay, or use low power networking technologies. Okay, so last one, okay, this is pretty interesting. Over the past 10 years or so, okay, we are seeing more and more user interface or user experience paradigms, okay, being introduced. And UI, user interface design, basically helps to reduce energy consumption in a mobile device. Okay, for example, minimize the amount of screen updates. Okay, so if you look here, okay, if you try to compare, okay, reading an article, okay, over a static screen, and then you try to read something which is basically on Facebook or Instagram or Twitter, which basically refreshes all the time. Okay, you will notice that, okay, reading a static page compared to a dynamic page, a static page consumes less power. Okay, try to use as little animations as possible, okay, and try to avoid unnecessary UI elements. What are unnecessary UI elements? Okay, probably I'll just ask the first question in this class, okay, in this lecture. How many steps, okay, how many steps is the maximum step in a typical form? You know, when you try to purchase something, for example, if you go to Amazon or you go to Shopee or you go to Lazada, I don't know, there are so many shopping or you know, if you just go to AirAsia or you just go to any business website today, okay, try to do an e-commerce transaction, what is the number of maximum steps required, okay, for you to do a transaction? Can anyone tell me that? If you know the answer, you can write it on your meeting chat. Or you can just, you know, say it on your screen. Yes, Nabila, okay. 3 to 5 steps, that's the right answer, okay. Maximum is 5. Let's look into a typical website, okay. For example, AirAsia, okay. You basically go into your website, okay. You choose your flight, you choose your seat, you make your payment, and it's all done. Maximum is 5 steps. Anything more than that, okay, will make the user experience not really pleasant, okay. Hence, okay, people will not basically use your particular service, okay. But in terms of software, okay, we try to use the same concept as well. Anything more than 5 steps is not right, okay. So we try to reduce that so as to conserve energy in terms of our mobile devices as well, okay. So we have come to the 3 different steps, okay, 3 different approaches, okay, in terms of energy conservation on a mobile device, okay. Now, we have come, okay, to something that is much more recent today, okay, the Internet of Things, okay. So, I'm pretty sure most of us here have come across IoT, okay, and the definition of IoT is that it is actually a network of physical devices, vehicles, home appliances and other items embedded with electronics, software, sensors, and connectivity, which enable these objects to collect and exchange data. Okay, so if you look here, there are 4 elements that we talk about IoT. Okay, the first one is you have your electronics. Second one is you have your software. Okay, third one is you have your sensor, and then of course you have your connectivity and processing. Okay, so these are the 4 different elements. Without any of these 4 elements, then you basically do not fulfill any of the definition of IoT. Okay, so when I started playing with IoT, okay, back in 2015, okay, it was basically simple things like measuring humidity, measuring the pH of water, measuring temperature, so on and so forth. Okay, that was basically Internet of Things. Okay, but today, okay, some people have actually coined up the term of Internet of Everything. That means everything has its connectivity, everything has its processing, everything has sensor, everything has electronics and software. Okay, and I'm not surprised, okay, that the amount of activities that we can actually do in terms of IoT. Okay, for example, you can do your home monitoring, you can do your security, you can do your traffic monitoring, you can do your smart factory, smart manufacturing, agriculture, even to the point of your own body. Okay, you try to measure what is your blood pressure, what is your sugar level, what is the temperature, so on and so forth. Okay, so when you look into IoT, when you look into Internet of Everything, okay, sensors, electronics, so on and so forth, the requirement for power is increasing every day. Okay, yes, IoT sensors, IoT processing, they came up with a way of ensuring little energy is being consumed. Okay, for example, data transmission in an IoT is always very, very small packets, very simple packets, to the extent that sometimes if you're talking about data transmission over a network, it's always not encrypted. Reason being so is that we try to make it simple. At the same time, okay, we try to not to have many computational power. But the drawback in terms of that is that you have security issues. Okay, so let's look into all these different types of IoT that we have around. IoT electronics, IoT retail, IoT automotive, IoT insurance, IoT manufacturing, IoT energy, IoT industrial, IoT aviation, IoT healthcare. There are so many things involved. Okay, so if you are interested in terms of working with IoT, okay, then of course there are many, many applications that we can actually do, okay, in terms of coming up with different solutions to that. Okay, it was just 2 weeks ago, okay, where my students and I, okay, we got involved in an IoT project, okay, basically to make sure, okay, or to make or to conserve, okay, rivers in Malaysia. So if you notice, okay, most rivers in Asia, be it Malaysia, be it Indonesia, be it Thailand or the Philippines, okay, one of the biggest problem with not Malaysia, one of the biggest problems with Asian countries is that our rivers are basically dirty because people throw rubbish into it. Okay, so what we have devised here is that, okay, a solution where we put up nets, okay, across the river, okay, and these nets will basically capture the rubbish that is being sent around. Okay, so what happens now is that, okay, every now and then, okay, the city council or the drainage department will come and remove the trash, okay, probably every 3 or 4 days once. Okay, most of the times, okay, the rubbish has actually filled up the particular area, and sometimes, okay, it basically push, okay, the net, breaking them, and then the rubbish basically goes back to the ocean. So what we do here is a very simple solution. Okay, we came up with a sensor, okay, to measure stress, okay, a spring stress. So whenever the tension actually is there, okay, it reaches a certain threshold, it uses simple LoRa technology to transmit a message using cellular network to a particular place with a GPS location so that people can come and remove that particular trash. Okay, so that is one of the simple things that we have done. Okay, and we are currently testing out this particular project. Okay, with an NGO, non-governmental organization in Kuala Lumpur. Okay, so we try to see what we can do in terms of Internet of Things. Okay, but let's go back in terms of what we can do. Okay, in terms of energy efficient IoT. Okay, so as I mentioned earlier, okay, if we talk about IoT, okay, we are basically not talking about 2.4 gig. We're not talking about 5 gig anymore, okay, because of its proximity, okay, its distance. So what we want to do here is that we want to use low power connectivity, okay. Low power connectivity here also means that we are using a different wavelength, different frequency in terms of transmitting. The shorter, the lower your frequency, the longer your wavelength, okay, so you can transmit basically over a longer distance, okay, but okay, you need to actually have very simple packets, simple message, okay, so that it is understood. Very little transmission, okay, very little interference, okay, so that you can actually receive your packets efficiently. So examples of low power connectivity here refers to ZigBee, okay, or even LoRaWAN, okay, a long range wide area network. Okay. Next one, okay, is to use energy efficient sensors, okay, optimize data transmission. Okay, so this is one of the most important thing that we see here nowadays. Okay, optimize data transmission here means that we try to send message as simple as possible. You know, if you look into data transmission on a typical TCP network, it's basically 128 bit, 256 bit, 512 bits. Okay, but for a typical data transmission over a simple network, okay, sometimes it's just 52 bits, sometimes it's just 128 bits. Okay, just for us to be able to send, okay, simple messages over the network, and at the same time it is always non-encrypted. Okay, we also look into power management over here. Okay, so when we talk about power management in terms of energy efficient IoT, what we try to do here is that we try to capitalize on the duty cycle of our IoT devices. Okay, so we look into active, idle, as well as sleep. Okay, so depending on the type of application that you are actually developing, if it is a time critical device, meaning that your device needs to refresh, sense data regularly, then the drawback here is that, okay, you're consuming more power. However, okay, if your data of your application does not require constant data transmission, then you can actually lengthen the power, the period of time before you send the message, okay, so that you get to use your device for a longer period of time. Let me just cite you a very simple application that we developed about 4 years ago. Okay, one of the biggest problems that we face here in Malaysia is that illegal logging, okay, chopping down trees. So what we have done here is that we have actually fixed, okay, a device, okay, an application which we put it on a tree. Okay, so what happens here is that, okay, as long as the tree is still intact, nobody chops off the tree, your device does not send anything. Okay, but when the tree is chopped down, the moment it hits the ground, there is actually vibration. Okay, when the vibration actually happens, it powers up your device, and your device basically send a message to the closest access point, okay, basically to tell you the location of that particular tree. That is where we know that the tree has been chopped off, and we can send our rangers to make sure that no trees will be chopped off illegally. Okay, that's a very simple, that is actually a very simple application to ensure that our forests are actually being taken care of. Okay, next thing is edge computing. Okay, edge computing here refers to the process where we do not process our application, okay, on a server or any other sites, but locally, but just simply locally. So which means that, okay, everything happens in the device before it is sent. That way, okay, we are basically reducing the traffic from your device to your server and then to another particular application. Okay, so that is basically edge computing. Lastly, okay, is the use of renewable energy. As much as possible, if you're able to use recyclable energy, if you're able to use solar energy or so on and so forth, try to use it in IoT. Okay, early February the other day, okay, what happens is that we engage with a primary school here in Malaysia, and we basically regulate watering system for the farm. Okay, so instead of using energy, instead of using battery technology or even direct supply, what we do is that we provided them with solar energy so that the plants will be watered based on an interval, okay, and it's powered by basically solar energy itself. Okay, so these are examples of how we can use IoT, energy efficient IoT, to make sure that energy is conserved. Okay, so we have come to the conclusion of our talk today. Okay, and let me just do a simple recap, okay, of what is being presented. Okay, so the very first point, the very first takeaway of this whole presentation, okay, almost an hour, is an increased number of mobile devices and IT applications. So we saw 14 billion devices, okay, more and more applications, more and more software being developed. Okay, so there is actually a very great need, great demand for energy. Okay, so it is imperative that energy conservation takes place. Okay, and I've mentioned to you, okay, there are basically three fronts in terms of conserving energy. First is hardware. You can look into battery technology. You can look into regulating the radio interfaces. You can look into reducing screen time. You can reduce the number of processors, so on and so forth. Okay. We also look into software. Okay, optimization in terms of your code. We try to improve in terms of the user interface. We try to do so many things, with regards to software for energy conservation. And finally, okay, where I truly enjoy working is basically in terms of network protocols, where I shared with you some of the works that I have conducted. Okay, we look into TCP wake up, we look into VINA, okay, and a few other researchers, for example, EEMAC. Okay, basically EEMAC stands for Energy Efficient Medium Access Control, where we try to reduce the number of layers. Okay, you know what's a MAC layer. Okay, so we try to reduce the number of MAC layer. We try to reduce the number of overheads. Okay, in a medium access control, so that more and more energy can be conserved. Okay, so this is basically the presentation that I can share with you. Okay, and I am now open for question and answers. Okay, thank you.
We will now proceed with the Q&A session. For this Q&A session, we will open two sessions. The first session is for the participants who are attending in this room, and the second session for the participants who are attending via Zoom meeting. Please note that I will be translating any question in Bahasa Indonesia for Mr. Charan, and Mr. Charan will answer in English. Kindly keep your question clear and concise for the benefit of all attendants. Jadi kita akan buka sesi pertanyaan. Untuk sesi pertama kita buka dulu untuk yang peserta ada di ruangan ini. Jika ada yang ingin bertanya bisa angkat tangan lalu sebutkan nama dan pertanyaannya. Pertanyaan pertama dari Pak Jeffrey.
Oke, terima kasih. Thank you, Charan, for the great presentation. Yeah, it's quite hard for me to understand for the first slide, but after that, I enjoy your presentation. So I get some insights about energy saving in mobile phones or in Internet of Things overall.
Jeffrey, I can't hear you.
Oh. Hello, Cherin.
Yes, okay.
Okay, good. Thank you for the great presentation. Yeah, it is quite hard for me to understand about your slide for the first time. But after that, after a great explanation, I can enjoy your presentation, and I got some insight about the energy saving. And I see there are some solutions that you provide in terms of software, how to save the energy. My question is, what is the potential research related to information system that we can do, my student do in this field? I see that from the setting of computer, I see that some software sometimes need energy consumption, but others not. So my question is, what is the potential research for the information system student related to energy saving? Thank you very much, Kevin.
Okay, thanks, Jeffrey, for the question. Okay, so I'll try to look at your question, okay, from a wider perspective. Okay, so when we look into optimization, okay, especially with relations to AI, so and AI is definitely one of the biggest trend that we actually see today. Okay, we are getting more and more data coming in. Okay, volumes of data. If you're talking about big data, so on and so forth, you have different types of data. You have volume. You have, of course, veracity. Okay, so to basically process the data, cleaning them, so on and so forth, and then coming up with good decision making. Okay, when you talk about information system here, okay, is that you need to optimize your software. You need to optimize in terms of your processing, how you come up with a good solution in terms of your application. Okay, so if you look into machine learning, okay, one of the things that we basically look into nowadays, okay, we are getting so many gigabits of data minimum. Okay, we are basically getting petabytes, so on and so forth, zettabytes of data every day. Okay, so the question here is that, okay, how good are we in terms of being able to understand which is the best data, how do we clean the data, and then finally coming up with a decision. So the process of, in terms of coming up with all these different processes to come up with a good solution, to come up with a good decision, okay, is of course one of the biggest challenges that we actually have around. That is in terms of data optimization. Okay, in terms of, you're talking about information system. Okay, if we talk about information system, looking into information management, okay, then I think so the biggest role here is that in terms of data retrieval. Okay, so what is the biggest challenge that we have nowadays? Okay, when we talk about assessing so many databases, okay, so many data resources, okay, is software optimization. Okay, so which is the best that we can actually get? Okay, so if you look into one basic database, for example, okay, it's not just as simple as reading lines and lines of a table. If you have relational databases, you're trying to read from so many different resources together. Then the biggest challenge here is that, okay, how best can we get the right information? Okay, how best do we traverse that particular table in terms of trying to read into that? Okay, so that is, I think so, two of the most important things, okay, in terms of how we talk about optimizing or conserving energy in an information systems environment. Okay, that is, I think so, my input in terms of your question, Jeffrey.
Thank you so much, Sharon.
Yeah, Nazaruddin, do you have a question?
Oke, yang ada di ruangan ini ada yang
There are two questions here. Probably I'll answer both of it. Okay, the first one is that how can IoT be utilized in the development and implementation of smart cities, including in areas of energy management, transportation, and the environment? How can IoT assist in digital transformation of industries, including IR 4.0 and smart manufacturing? Okay, there are two questions over there. Okay, the first one is implementation of smart cities. Okay, so when you talk about implementation of smart cities, again, looking into energy management, transportation, and environment, I think so. This is very timely. Okay, most of issues related to smart city are derived from these elements over here. Okay, when you talk about smart cities, okay, it's not just basically the whole city by itself. You look into every different aspects of smart city. Okay, so if you look into a smart home, many homes will come up to a smart city. Many industry will come to smart city. Many manufacturing will come into smart city as well. Okay, so we try to actually look into all these different requirements. Okay, when you talk about smart homes, okay, so basically you're talking about monitoring. We're talking about coming up with good what they call this materials, okay, as well as how do you basically come up with in terms of you talk about material, you talk about energy, and so on and so forth. Okay, so it not only looks into the IT part of it, basically, it also look into the policy part as well. Okay, so it has to be balanced on the both side. Okay, if you look into the technology side, okay, of course, when you talk about smart city, is that monitoring of emission of gas. We're talking about monitoring in terms of how water is being used, how clean is your air, how much energy is being used. Okay, all these things are simple. All these things are very, very simple. Okay, but if you try to look at a policy point of view, okay, then this poses a different challenge altogether. Okay, policymakers are always the biggest problem makers of all. Okay, it's easy for you to develop something. You can easily program something because you can basically talk to a machine. But try to talk to a human being, okay, that is the biggest pain, okay, that we all face actually. So different policymakers have different interests, okay, and it's best, okay, to basically suit into all these different requirements to make sure that good mechanism, good policy of smart cities are in place. Okay, if you talk about manufacturing, how much gas can we actually emit? What is the best terms in terms of coming up with waste processing, so on and so forth. So that is one thing. Okay, in terms of transportation, this is one of the biggest problem that I think so Jakarta faces, one of the biggest problem Kuala Lumpur faces, one of the biggest problem Bangkok and Manila actually face. Okay, so one of the biggest thing that we can have here is that, okay, smart transportation system. Okay, I think so the Indonesian are doing a good job in terms of the BRT. Okay, but we haven't seen much being done, especially in Malaysia, in terms of how we can regulate public transport. Okay, in Malaysia, basically, having a car is a status symbol, so everybody must have a car. Okay, so when you have too many cars on the road, then you're not basically doing anything in terms of traffic management. All right, in terms of IR 4.0, okay, I think so there's so many elements in IR 4.0, okay, and one of the biggest thing in terms of IR 4.0 here is the usage of sensors, the usage of AI, the usage of smart materials, so on and so forth. Okay, again, okay, IR 4.0 does not work only on a single element. It has to work on every element to see that how we can interrelate. Okay, the concept of if you have actually come into the theory of singularity, have you actually heard of that theory of singularity? It means here is that, okay, there is nobody who can work alone by itself. Okay, everybody has to be connected to one another. We are able to basically form one concept, and that concept basically works. That is theory of singularity. If we look into how we work on IR 4.0, apply it to the concept of theory of singularity, work in together collaboratively, then what we can do is that we can solve many problems together. Okay, so Aniso, that answers. I hope that answers. Okay, the question from our first participant. Yes, can I have the question from Mr. Nazaruddin?
Okay, thank you. Moderator, may I have a question?
Yeah, sure.
Okay, thank you, Professor. Your talk is very great, and I like it. You have explained a lot about software to reduce the consumption of energy in our mobile phone. So my first question is, how many percent we can reduce the consumption of energy if we try your software or your proposal how to reduce the consumption of energy. I mean, with all effort, you have tried to pursue people to do that. How many percent we can reduce for each smartphone? And is it possible also we use the same thing with the all mobile phones, such as we call in Indonesia jadul zaman dulu ya, all version such as Nokia version something. And the second question is, when I was in London, one of my friends from architecture department, they tried to find out with the software and hardware. They combine software and hardware. The architecture department collaborate with computational department. They try to make software and also hardware and put in our room. And I was one of the volunteers to join their research, and they put the software, the hardware and software in our rooms, so they can collect the data, how many energy we consume every day to get heat up our rooms. So is it possible? What do you think? Is it possible we just use our mobile phones to collect the data? I mean, for Indonesia or Malaysia, maybe how many energy consumption every day to for using our air conditioner, maybe, or something?
Yep.
What do you think about this? Thank you very much for your response.
Sure. All right, thank you, Mr. Nazaruddin. Okay, so I think so there are two questions that you have actually posed. Okay, so the first one is in terms of using software for energy consumption. The second one is in terms of using different appliances. Okay, let me just answer the second one first. Okay, one of the things that currently taking place, okay, all around the world today is that how do we audit energy? Okay, energy auditing. So basically what we can do here is that we try to actually look into a single usage, okay, of a single user, or a collective usage, okay, for example, a faculty or a university, okay, in terms of energy usage. So we try to see, we audit, okay, how much energy is being used, okay, how much energy is being wasted. Interestingly, there's a lot of energy that is being wasted. How much energy leakages that we actually have. Leakages here refers to, for example, you just take off your plug without switching off your power. Okay, so energy leakages actually does happen as well. Okay, so energy auditing is is currently being carried out extensively in a lot of organizations, mainly to the fact that, okay, we realize that energy costs has actually increased over time. Okay, for me, let me just share with you. Okay, it is expected, not easy expected, it is estimated that University Utara Malaysia spends almost $200,000 a month on energy. Okay, so through air condition, through fans, through all these different appliances, it comes to about 200,000 USD a month. That's a lot of money. Okay, so if we can basically reduce the usage of appliances, for example, we use smart technology. Okay, when there's no student, we switch off the lights. When there's no student, we switch off the aircon. We only use LED street lamps and so on and so forth. Then we can basically reduce, okay, our energy cost per se. Okay, so that is the first question. Did I answer your question, Mr. Nazaruddin?
Yeah.
Okay, all right. So for the second, for the first question, okay, in terms of the usage of software, okay, well, I can say, okay, how we use software to conserve energy is basically tightly related to our usage behavior as well. Okay, so, well, if let's say two users were asked to use a simple application. Okay, let's say they just have to use Facebook, for example. So one is to use it continuously from 9 a.m. to 1 p.m. The other one is to use 9 a.m. to 10 a.m., stop 11 a.m. to 12 a.m. every 1 hour. Then we can basically see that the usage pattern would be different. Okay, but that is, of course, very social science kind of research. Okay, but in terms of looking into algorithms, looking into how we can basically address software approaches for energy conservation, okay, I believe there's a very strong need for us to be able to optimize so many things, especially in terms of processing. Okay, so if you, Nazaruddin, if you remember, okay, back then we used to have very simple transaction management approaches when it comes to processing, is that every form is filled in and then it is sent over to a server. The server will check and then you'll tell us that, hey, you need to fill in this particular field. Then you send again. So that is what we call as the processing that is happening on the other side. So what we do now is that we try to basically, there is a server-side processing. Now what we do now is that we try to have client-side processing or edge computing. That basically solves a lot of problems. Okay, another aspect which I'm really interested in is that the usage of AI in terms of optimization, software optimization. I think people should learn how to code efficiently. Okay, yes, every first year student in every university were taught, okay, if else then, okay, if then, all this kind of thing, do while and kind of things. But did we actually tell our students that, not only do we need to code, but we need to also understand the efficiency of the code, the efficiency of an application. What happens to, learning about O log n? Okay, that will basically give us the understanding, okay, by that, how efficient our code is and how does it actually impact the efficiency of our software that we actually develop. So from the software perspective, okay, I really believe that there's a lot of things that can actually be done. Okay, if you actually go to some websites, take up some academic papers, try to read how impactful software is towards the income or the revenue of certain organizations. For example, okay, try to see, okay, what happens if Amazon, what happens if Google, what happens if Netflix, they are unable to, process in a very quick manner, how much money do they actually lose, in terms of that. So, you know, yeah, you asked a good question. I didn't have the time to actually look for this kind of question answers. Okay, but yeah, if you have the time, okay, this is where software optimization, this is where intelligence, efficient intelligence actually comes to play. Yep, hope that answers you.
Yes, of course, this is answer my question. And also, I want to tell you, I appreciate you explained before when you, in your presentation, you explained about the Max Planck equation, the relationship between frequency and energy consumption. This is very good. I think this because I'm a lecturer in chemistry, and I talked to my student about what is this, quantum chemistry. So it's related my also related my my lecture. Thank you very much for the presentation, a very good presentation.
Thank you for your question. Okay, we have another question here from Fitri Dwi Lestari. Okay, so good morning, sir. May I ask a question? Yes, you may. In the era when all of things that we consume, all the things consume a lot of energy, is reducing our consumed energy better than searching for renewable energy? Because I think in the future, people will also use more bigger data and consume more energy. So how important is to reduce our consumed energy? Okay, so Fitri, okay, thank you for your question. All right, reducing energy and renewable energy, they actually come hand in hand. You cannot say no to one and do the other, or do the other and say no to one. Okay, so for example, let me just share with you here. Okay, reducing energy, of course, is a very important thing. Okay, we try our best not to impact the environment anymore. But at the same time, okay, technology for renewable energy is still in its infancy. Okay, masih, if I may say it in Malay, okay, masih dalam penyelidikan awal. Okay, so when you say about hydroelectric, when you talk about solar energy, when you talk about wind energy, okay, well, these are all technologies that have proven, okay, but there are also other renewable energy that has yet to be actually fully explored. Okay, well, now let's look into reducing energy. Okay, if you're talking about coal, arang batu, okay, or if you're talking about petroleum, okay, well, these are all resources that is depleting, okay, and we need to reduce the usage of hydrocarbon, okay, derived from this source of energy, mainly because all these resource of energy bring negative impact to the environment. Okay, so to say which is better, okay, of course, we want to reduce hydrocarbon, okay, and at the same time, we want to speed up the usage of renewable energy. Okay, well, if you are really keen about finding out about this, okay, there are currently efforts, okay, in terms of people coming up with community energy generation, which means that, okay, we do not rely basically on huge power stations anymore. We do not rely on big initiatives, okay, but as long as we are capable of producing our own energy, then this is what we want to do. For example, okay, in Australia, where I saw a very recent project being conducted, okay, is that every home in Australia, they are encouraged to fix solar power energy. Okay, so sun will actually go to the solar panel, okay, and then the energy will then be channeled back to the utility company, okay, and during that particular process, okay, they actually generate income, okay, and then the energy is actually being sold back to the household. So what happens here is that, okay, you are basically generating your own energy, we're basically generating your own income for your usage at home. Okay, that is one thing. If you're talking about transportation, Okay, we do not want to talk about biodiesel. We do not want to talk about petrol. We do not want to talk about diesel. But we're talking about biodiesel. We're talking about usage of electric vehicles. Okay, something that is definitely my interest now. Okay, is to use the electric cars. Okay, in terms of how we can actually use to reduce energy consumption. Okay, so future people will use bigger data. Exactly, more and more data will be used. Okay, and yes, we will consume more and more power. Okay, but if we are capable of producing or renewing our energy, then this shouldn't be a problem anymore. Okay, so does that answer your question, Fitri?
Oke, yang bagi yang peserta yang ada di ruangan ini yang ingin bertanya, silakan. Halo.
Yes.
Check. Mr. Karim, in the past
Hi.
2 years, can you hear me?
Well, Shireen, did you remember when you were in Jambi?
Yes, I do.
Yeah, I was one of the lecturer from the University of Jambi, followed the trip to Tangkit.
Yes.
Tangkit Baru. Yeah. What's the reason coming? I mean, what's the outcome of the research?
We conducted some requirements analysis on that. Okay, but it didn't actually seem to be something that is workable at that point of time. Probably there is a greater need for similar initiative now.
Yes, it's great. My team and I currently have we call the pengabdian masyarakat, public services.
Okay.
And Tangkit, and this is to name Tangkit Baru and Tangkit. We were in Tangkit Baru, where the plantation.
Yep, the pineapple plantation.
Oh, pineapple plantation, yeah. It's quite good, I think.
Okay, Mr.
So
Nasir.
yeah.
Yeah, and so
like this.
Coming in.
Sorry.
Yeah, the student who stood up earlier.
Yes. Mr. Tarin, am I audible?
Yeah, yep. Good.
Oh, okay. Mr. Tarin, in the past 2 years, metaverse become a trend in our society because it becomes a thing in our society. If metaverse really happened in our world, it needs a lot of electricity. And while metaverse is really complex, it requires when we do the transaction, cryptocurrency transaction, it needs a lot of electricity and it needs a lot of energy. Could IoT minimize energy usage, and could IoT minimize the damage that could affect our environment? Thank you, Mr. Tarin.
Okay, interesting question. Okay, all right. If you look into metaverse today, okay, so basically it's a different world altogether. Okay, but well, we talk about metaverse, it definitely requires a lot of processing involved. Okay, so going by what is happening today, okay, yeah, metaverse basically is well, adding on to the energy requirements that we currently have. Okay, and if you're talking about metaverse, okay, sometimes we do our transactions. Okay, it can be in fiat money, it can also be in terms of digital money. Okay, some in terms of certain cases, we do our transaction in Bitcoins. All right, when you talk about Bitcoins, okay, mining for Bitcoins requires a lot of energy. Okay, so in that sense, again, okay, concept of metaverse, concept of digital coins, digital money, it does actually have some negative impact in terms of our energy consumption. But I am not saying that we cannot use metaverse. Okay, I do believe that there are a lot of potential that it can be derived out of all these digital fronts that we currently have. Okay, and there are many good things that can come out from that. That's a particular first thing. Okay, in terms of IoT and metaverse. Okay, as I said earlier, okay, when you talk about metaverse, it's all about consumption, adding in AI, adding in computations, so on and so forth. Okay, if you're talking about reducing energy from the point of IoT, okay, then one of the solutions that we can actually have here is that in terms of reducing computations, how do you come about reducing the number of processes, the complexity of the algorithms? The second thing is that how efficient it is, okay, in terms of your network usage. We try to come up with green network. Okay, green network is something that we actually really want. But okay, the thing here is that it's not about the network per se, the computation per se. When you're using a device, okay, something like this, okay, to go onto your metaverse, okay, then we also need to improve in terms of the efficiency of a device like that. So it does not only come basically at IoT, basically come at computations and so on and so forth, but it has to be coming in from all different aspects in terms of how we can best use metaverse for every activity, for most of the activities that we're trying to have here. Okay, again, okay, metaverse is good. Metaverse has a lot of potential. It has, of course, okay, it has, of course, some environmental impact in terms of energy, okay? But hey, we are living in a world that nothing is good. Kita bukan di surga, okay? Sometimes you have something that you need to trade off in terms of coming up with good solutions, good applications, so on and so forth. All right? Does that answer your question?
Yes, Mr. Charin. Thank you.
Okay, cool.
Answer.
Okay, thank you, Elton, for the question. We will open one more question for the participant in this room only, not via Zoom. Buka sesi satu pertanyaan lagi untuk peserta yang ada di ruangan ini. Ada yang ingin bertanya? Sebutkan nama dan pertanyaan.
Yes. Good morning, everyone. My name is Asirman Jaya, pass of student information, pass of 2022. Until now, the manufacture of mobile device using recycling system has only been carried out by the Apple company. While the increase in the use of mobile device is getting higher every year, with the negative impacts that have been described regarding the manufacture of mobile device. What is the best solution that can be implemented so that each mobile device that is made doesn't have a greater negative impact on the environment? Thank you.
All right, thank you for your question. Okay, this question is okay. I'll answer this question from different cabang there. Yeah? Okay, so when we talk about mobile devices, okay, the hardware, right? One important thing that we need to see here is that okay, we need to come up with better materials, better components, okay, in terms of battery technology. Okay, so as I mentioned earlier, we're talking about lithium ion. Okay, we're talking about lithium polymer. We're talking about nickel cadmium. We're talking about you know, all these different types of technology. Okay, if and until okay we find a different material in terms of how best can we come up with a source of energy that is high in terms of capacity, low in terms of environmental effect, okay, we can just do best with whatever that we currently have. Okay, I believe that there are many researches that is being carried out. For example, solid state battery components, okay, that will actually prove to be much more efficient in terms of powering up our devices. Okay, that is from the hardware point of view. Okay, we cannot pinpoint to say that, okay, most of the devices are Apple. I believe that if you're talking about any other mobile devices of any make, of any brand and so on, so okay, and any make of brand, okay, the components or the ingredients of your particular battery, okay, is almost the same. Okay, it's just how much efficient are we in terms of addressing our power usage. That is the second thing. All right. Now, the third thing here is that, okay, one of the biggest problems that we're currently facing here is that the disposal of our mobile device. Okay, yes, we are happy when we buy it. Okay, but after 2 years, after 3 years of not using it, okay, or once you find that you're no longer happy with your device, okay, what do you do with it? Okay, some of us will just put it into our drawer, keep it for another 3 or 4 years until it's fully obsolete, and then we throw it away. Okay, some of us will just, like, you know, get a new iPhone and then, yep, okay, I'll just leave it somewhere else. Okay, but and also one of the biggest things that we can do here is that, okay, proper disposal of our devices. Okay, in Malaysia, you actually have places where you can drop your mobile phone. Okay, you drop your battery once you find it that it's no longer performing to the capacity that you actually want it to be. So there needs to be awareness, okay, among people today that environment protection, okay, disposal of electronic goods, okay, is something that has to be taken very seriously. We need to make sure that, okay, properly discard of all these different components. That's the second thing. Okay, the third thing, always look for energy efficient devices. Okay, if you buy any devices, okay, there's actually a star rating on that. Sometimes you see a 1 star, sometimes you see 5 stars. Okay, so always go for a 5-star device. Okay, because 5-star device means that it has been tested, it has been proven to be energy efficient. That is the most important thing. So these are among the few approaches, okay, that you can actually use to make sure that conservation of energy is ensured. So yep, that is my answer to your question.
Okay, thanks to every participant who has asked, and Mr. Cherin for extraordinary answer. And for that, we would like to end the Q&A session for this public lecture, and then moving on to the concluding remarks. Kesimpulan yang dapat kita ambil dari kuliah umum pada hari ini adalah terdapatnya revolusi yang terjadi pada perangkat mobile yang ada sejak tahun 1973 hingga saat ini. Dari bagaimana teknologi berevolusi, seperti yang dipresentasikan tadi, sebagai contohnya adalah handphone, dari generasi ke generasi sampai dengan pertama kalinya dikenal iPhone. Secara tidak sadar, semakin canggih teknologinya, semakin tinggi juga penggunaan powernya. Dengan bagaimana di dalam kehidupan sekarang, kita tidak bisa lepas dari HP dan penggunaan teknologinya. Dan semakin kita bergantung pada teknologi, semakin terhubung kita. Semakin banyak energi yang kita gunakan, sehingga semakin banyak karbon dioksida yang kita keluarkan. Dan ini memberikan dampak buruk bagi lingkungan kita. Kita sebagai generasi sekarang harus berhati-hati dalam menghadapi permasalahan ini. Inilah mengapa kita belajar mengapa menghemat energi itu penting dalam menghadapi masalah ini. Penerapan sebagai efisien yang dapat kita lakukan dalam menghadapi permasalahan yang ada dari dampak buruk perangkat mobile. Solusi yang dapat digunakan adalah dengan menerapkan Internet of Things tadi, yakni ada 3 bagian yang diambil. Pertama adalah hardware, lalu internet, dan terakhir adalah software. Untuk menerapkan solusi dari perangkat hardware sendiri adalah dengan menggunakan bahan adalah bahan yang digunakan dalam pembuatan setiap bagian dari perangkat mobil sendiri. Solusi yang dapat dilakukan dalam permasalahan jaringan adalah dengan menggunakan perangkat mobile dengan sebijak mungkin. Sebagai contoh, menonaktifkan perangkat ketika tidak digunakan. Seperti yang dipresentasikan tadi itu, dapat kita menerapkan mode sleep atau interface mati. Karena ketika kita menggunakan interface yang mati, ada yang namanya transmitter WINA dan receiver WINA. Dua ini berfungsi ketika kita dalam mode sleep atau interface mati. WINA akan menghidupkan jaringan yang relevan ketika misalnya HP menerima pesan atau notifikasi, sehingga dapat menghemat energi. Solusi yang dapat kita lakukan terhadap permasalahan software adalah mengatur penggunaan power yang ada berdasarkan aktivitas yang dilakukan. Sebagai contoh, menggunakan penghematan daya baterai atau penggunaan kecerahan layar dan sebagainya. We moving on to the concluding remarks. We extend our deepest gratitude to Mr. Cherin for sharing his time and expertise with us today. His research and insight have deepened our understanding of energy-saving technique using IoT technologies. We would like to express our appreciation to all of you who have attended and actively participate in this public lecture. Please give a round of applause for our distinguished speaker, Mr. Cherin. We hope that the knowledge gained from this lecture will help you further your career or just to expand your knowledge in general. And for that, my partner and I are done with our role as moderators, and we would like to give our stage back to our MC. Thank you.
Terima kasih kami ucapkan kepada moderator dan pemateri yang telah memberikan wawasan dan pengetahuan yang berharga dalam acara ini. Sebagai bentuk apresiasi, kami memberikan penghargaan berupa sertifikat yang akan dikirimkan oleh Kesekretariatan Himasi.
We would like to extend our gratitude to speakers for providing value insights and knowledge during this event. As appreciation, we will provide awards in the form of certificate which will be sent by the Himasi Secretariat.
Sebelum menutup acara, kita akan melakukan sesi dokumentasi. Diharapkan peserta yang terhubung via Zoom meeting untuk dapat mengaktifkan kameranya. Selanjutnya, panitia dapat mengarahkan untuk sesi dokumentasi.
Before closing the event, we will take some time to document this occasion. We kindly request that the participant in Zoom meeting turn on their camera and use the provided background. The committee will direct you for the documentation purpose. So, okay, you guys ready for documentation? Let's counting from 3, 2, 1. Again, next slide. Three, two, one. Next slide. Three, two, one. Okay, I think that's enough.
Selanjutnya untuk dokumentasi offline, silakan beberapa perwakilan peserta untuk maju ke depan.
For our audience, please stand up.
Akhirnya, seluruh rangkaian acara telah kita lalui bersama. Semoga dengan diadakannya kegiatan kuliah umum ini senantiasa membawa manfaat untuk kita semuanya. Saya Harinisa dan Sri Sulistina selaku MC mewakili seluruh panitia mengucapkan terima kasih kepada seluruh tamu undangan dan peserta yang telah mengikuti acara kuliah umum hari ini dari awal hingga akhir. Dan mohon maaf yang sebesar-besarnya apabila ada tutur kata yang kurang berkenan di hati rekan-rekan semua.
Finally, we have come to the end of the event. We hope that this public lecture activity will always bring benefit to all of us.
Saya dan Sri Sulistina izin pamit undur diri. Selamat pagi. Wassalamualaikum warahmatullahi wabarakatuh.
Kepada peserta diharapkan jangan pulang terlebih dahulu karena kita akan membagikan sertifikat. Terima kasih.
Okay, Cheryl, thank you for